Good morning friends. Today I am going to solve problem on one-dimensional wave equation. What students? One-dimensional wave equation. Let us see the problem students. A tightly stretched string with fixed endpoints x is equal to 0 and x is equal to L. That means, what is the string length students here? Say it is a and B. String length is L students. String length is L. Initially at rest in its equilibrium position. Initially at rest students. If it is vibrating by giving to each of its points a velocity. See students here. He given now velocity. Okay students, what is velocity here? Lambda x into L minus x. What is velocity students? Lambda x into L minus x. Lambda x into L minus x. So far we solve the problems which he given. What he given students? What he given? As initial displacement. What students? He given initial displacement. Now he given now initial velocity. Now what is initial displacement students? We are assuming it is 0. What students? Initial displacement is 0. So he given initial velocity students. Initial velocity. So lambda x into L minus x. Now what he says? Find the displacement of the string at any distance x from one end at any time t. Okay students, this is a little bit different problem students. Okay students, because he given initial velocity. That is the difference students. He given initial velocity, right? For this problem, what is wave equation students? Same, dou square y by dou t square, that is equal c square and dou square u by dou x square. Right. What is the soluble solution students? Soluble solution also same. Y of x comma t, that is equal to c1 cos px plus c2 sin px into c3 cos pct plus c4 sin pct. Conditions also same students. What are the conditions? Not all. Y at 0 comma t is equal to 0. Y of L comma t is equal to 0. These two are same. Now see students here. The change comes here. See y of x comma 0. Y of x comma 0 means here students initial displacement. What students? Initial displacement. Initial displacement is 0. Now initial velocity students dy by dt or dou y by dou t. T is equal to 0. So what is value students? Lambda x into L minus x, which is he given students. Which is he given. Now see students, if I am using this condition, what is the C1 value students? C1 value is 0 students. C1 value is 0. So we get here C2 sin px plus C3 cos pct plus C4 sin pct. And please remember here students, don't write directly. Don't write directly. To get 7 and 8, you can check the video of one-dimensional wave equation problem, lecture 1 students. I will provide the link in the description students. You can check there. Okay, and then from 4 and 7 students. What is 4? Y of L comma t is equal to 0. I am substituting here students. 7 is this one. Then I got here sigma n is equal to 1 to infinity a n sin n pi x by L cos n pi ct by L plus b n sin n pi x by L sin pi n pi ct by L. Now further I am using this condition students, initial displacement. So from 5 and 8 students, from 5 and 8. So what he given students? Y of x comma 0. So t value means t value is 0. So sigma n is equal to 1 to infinity. Where is t students? Where is t? Here we have t students. So cos 0 value is 1. Cos 0 value is 1. So a n sin n pi x by L. Sin n pi x by L. See students here we have sin t value is 0 students. So sin 0 0, since sin 0 is 0. Okay, finally I got here sigma n is equal to 1 to infinity a n sin n pi x by L. What is the value, students? This value y of x comma 0 value is equal to 0. This value is equal to 0. Now which is 0 here, students? Which is 0? Is sin n pi x by L is 0? No. Now which is 0, students, here? A n value is equal to 0. A n value is equal to 0 since sin n pi x by L is not equal to 0. Is not equal to 0. Now 8 becomes, students, 8 becomes what is 8, students, here? This one. So y of x comma t, that is equal to a n value 0, students. So you get here sigma n is equal to 1 to infinity b n sin n pi x by L into sin n pi ct by L. N pi ct by L. So this is 9, students. Now I am using condition 6, students. Condition 6. So I need here 6 and 9, students. 6 and 9. So I want to write here, students. What is 6 here? dy by dt or dou y by dou t at t comma is equal to 0, that is equal to lambda x into L minus x. What is equation number 6? What is solution, students? Y of x comma t, that is equal to sigma n is equal to 1 to infinity bn sin n pi x by L into sin n pi ct by L. What is the number, students? 9. I need these two, students. I need these two. Let us find which value, students? Which value? Bn value, students. Let us find Bn value. Let us continue, students. What is 6th equation, students? dy by dt t is equal to 0, that is equal to lambda x L minus x. See, students, I have here dy by dt. Okay, students, dy by dt. So differentiate 9 partially with respect to students t, with respect to t. So I get here dy by or dou y by dou t, that is equal to sigma n is equal to 1 to infinity bn sin n pi x by L. See, students, I have t here, students. I have t here. So what is derivative, students? What is derivative? Cos n pi ct by L, and again derivative of n pi ct by L is, students, n pi c by L, students. N pi c by L. N pi c by L. Okay, students. Now from 6, say this is 10, students. This is 10. From 6 and 10 we get what is dou y by dou t at t is equal to 0 value, students. T is equal to 0 value. What is the value, students? Lambda x into L minus x. Lambda x into L minus x. Now put t is equal to 0 here, students. Put t is equal to 0 here. Cos 0 value is 1, students. Cos 0 value is 1. So sigma n is equal to 1 to infinity bn. What is constant, students? N pi c by L. So n pi c by L into sin n pi x by L, students. N pi x by L. Now we need to find Bn value, students. Okay, students, to find Bn value, again we are using half range sine series, students. Sine So he given f of x, say in the interval 0 less than x less than c. What is Fourier series, students? Say f of x, that is equal to sigma n is equal to 1 to infinity bn sin n pi x by c, students. N pi x by c. How can you find bn value, students? Here 2 by c integral 0 to c f of x sin n pi x by c, students. Sin n pi x by c. See, students, here we have bn. Now in place of bn I have, students, here capital Bn n pi c by l. So bn, say n pi c by l into bn, that is equal to 2 by what is the length of the string, students? L. So 2 by l integral 0 to c, that means 0 to l. Now what is f of x, students? Here what is f of x? F of x is lambda x into l minus x. Now what is function here, students? Sin n pi x by l into dx. N pi x by l into dx. So that is equal to 2 by l into multiply, students, integral 0 to l. Lambda is constant, I think, so we can take outside, students. So lambda also take outside, so 2 lambda, okay, multiply with x, students. So get lx into sin n pi x by l into dx minus x into x square. So 0 to l, integral 0 to l x square sin n pi x by l into dx, bracket close. Now apply generalization of integration by parts, students. Integral uv, what is formula, students? uv1 minus u dash v2 plus u double dash v3 minus and so on. What is u here, students? What is u? Say lx. What is v? Sin n pi x by l. So that is equal to 2 by l into lx, integration of sin n pi x by, students. So minus cos n pi x by l divided by n pi by l, students. N pi by l minus u dash, derivative of lx is l, students. L, again integration of these, students. So we get a minus sin n pi x by l divided by n pi by l. Already I have n pi by l, students. So n pi by l whole square, bracket close. Both the integration limits are same, students. So I want to continue here. So minus x square, here u is x square and v is sin n pi x by l. So x square integration sin n pi x by, students. So minus cos n pi x by l by n pi by l. I have minus here, students. So minus bracket, put bracket, students. Minus, because in the formula I have minus here. Okay, derivative of x square is 2x, students, and again integral of cos n pi x by l by n pi by l, students. So get a minus sin n pi x by l divided by n pi by l whole square, bracket close. Then I have plus, students. Derivative of 2x is 2, bracket. So students, integral of minus sin n pi x by l by n pi by l whole square, students. So minus into minus plus, students, we get a cos n pi x by l divided by n pi by l, this time, students, whole cube, bracket, again bracket and again bracket. Okay, students, between the limits 0 to L, so that is equal to 2 by L bracket substitute upper limit students at the entire terms. So here I get here minus L square, that means here already I have substitute upper limit at x here students, so get L cube by n pi. See students, L by L cancel, cos we get cos n pi value is minus 1 whole power n students, minus into minus plus see students, here if you substitute L here, L cancel, sin n pi value students 0. I know here sin n pi value 0 and cos n pi value minus 1 whole power n students, minus 1 whole power n. So this term is 0 students. Now here students, here minus and minus plus, see students, L square, I have L here students, so we get here L cube by n pi, L cancel students, we get again cos n pi means minus 1 whole power n. See students, here again L cancel sin n pi value 0 students, 0, minus into plus, we get minus 2L by n pi, 2L by whole cube students, so we get here L cube by n pi whole cube students, so L cancel here, cos n pi value minus 1 whole power n students, minus 1 whole power n. Now substitute lower limit students, I have x coefficient here students, so the value is 0, sin 0 value 0, again I have x coefficient here, so the value is 0, again I have x coefficient here, so the value is 0. Finally I got here, see students, here minus, I am substituting lower limit, so minus and minus plus students, already plus here, so plus 2 cos 0 value students 1, so I get a 2L cube by n pi whole cube bracket, that is equal to 2 by L bracket, see students, here minus L cube n pi minus 1 whole power n plus L cube n pi minus 1 whole power n. These two are cancel students, cancel. Now see students, I can take in common here 2L cube by n pi whole cube students, okay students, 2L cube by n pi whole cube students, whole cube bracket, system minus 1 whole power n students, so it can be written as minus 1 whole power n minus 1 students, plus 1, okay. Now see students, I forget here lambda students, so put lambda. Now this L how many times? 2 times. Now see students, I have here n pi c by L bn students, so n pi c by L into bn, that implies I need only bn value students, so that is equal to 2 into 2 4 lambda square, 4 into lambda L square divided by n pi whole cube into, you take this right hand side students, we get here L by n pi c. Now see students, here minus 1 whole power n minus 1, so I want to take here odd students, n is odd means take 1 students, 1 minus 1 whole power 0, that means we get 1 student, 1 plus 1 2, 3 minus 1 students, we get 2, so minus 1 whole square, that means we get even term students, so we get here 2 students into 2. If n is even students, even 2 minus 1, we get minus 1 plus 1, so the value is 0, students. This is bn value. So therefore say substitute in 9 students, we get y of x comma t, that is equal to sigma n is equal to, see students, it is defined for odd term students, so n is equal to 1, 3, 5 and so on to infinity. Bn value is as a 4 into 2, 8 lambda L cube by, this is n pi students, so n pi whole cube into n pi, so n pi whole power 4 into c into sin n pi x by L, n pi x by L into sin n pi ct by L, n pi ct by L. This is the required solution of given problem, students. Once again, students, the previous problem and this problem difference is previously given initial displacement, students. Okay, initial displacement. Here he given initial velocity, students. So there initial velocity is 0. Here initial displacement is 0. So up to, you substitute the condition up to initial displacement, students. So what is last condition, students? dy by dt t is equal to 0, that is equal to lambda x into L minus x, initial velocity, students. Now up to you get here the solution, students, this one. Now you differentiate this with respect to t, okay, and then put t is equal to 0. Put t is equal to 0, we get this equation, students. Now here onwards you apply the concept of half range sine series, students, half range sine series, okay, and simplify it. Finally got bn value, students, bn value, and you substitute bn value here, then I get the required solution of given problem, students, given problem. Please like and share this video, students. Hope you understand. Thank you for watching this video. Jai Hind.